So this is a mod to the Korg ms20mini that adds the OTA filters like in the ms20 rev2, and you probably pretty much know about it if you're watching this vid, so I won't talk too much about all the history behind it or whatever. But anyways, here's the Korg 35 kind of BJT based filter down there, and there's the new OTA based filter up here. And for this mod you also have to add a bunch of analog switch chips, so there are 5 in a row here, and there's one right there, and those are DG205 switches. You can look those up on Google. And you have to remove the 0-ohm resistors that were on the board. Those make the connection to the old style filter, and you have to remove those so the switch can switch those connections off. And a few, system level kind of things come up, like I had to reduce the gain of this op amp that sums the two oscillator signals together, and reduce the amount of voltage division that goes into the first BJT based filter, so that the amplitude going in and out of the two different filter types was roughly equivalent. And I did a bunch of other tuning to make sure that the controls respond the same, or roughly, between the two filters. They're never going to line up right on top of one another, which would be nice, and but this is a fragile PCB and it's difficult to work on, so that's why you can't line them up perfectly. On a breadboard it'd be a lot easier, but then I have some through-hole resistors for the surface mount diodes. That's kind of ghetto, but it's what I had. I didn't have diodes in that footprint. I think it's like a SOT 323 or 523, or not a SOT but a SOD, SOD, all these stupid diode packages. So there's the 13700, there's an OPA 2209, it's just a nice audio op amp I had lying around that's dual, and this is the PNP matched pair. I figured out what the component is on that, so stay tuned for the schematics. And there's a low pass filter, all the switches. It's a little rework I did on the Korg 35 filter, because I replaced those op amps for some nice low noise ones, but that didn't really help reduce the noise much. There's that other switch. So that's all the crap I added, and if that's all there is to it, I'll show the schematics and do a little A/B demo with the panel back on. So I'm going to post pictures of the schematics, but I thought I'd point to a few things and talk about it a little bit. There's the PNP match pair, so you can look that up. That was important to find. It's just a PNP pair that's in that footprint that's Japanese, so I'm pretty sure it could likely be the right part. There are a few things to know, like if you do this mod and you don't like the resonance control, this would be a resistor to change. So you would decrease that resistor if you got too much resonance at your max setting, and increase it if you don't have enough resonance at your max setting. Just a thing to note, because I've only done this once and I don't know how this is going to act if somebody else puts this together. There's the one diode thing. Let's see. Yeah, and a lot of these other components I just kind of changed to tune the filter. But if you do this mod and you want to increase the amount of modulation you're getting out of the envelope or the LFO or the knob that's connected to the cutoff frequency, excuse me, these are the resistors to use. This resistor is pretty noteworthy. I had a lot of problems with I initially didn't have this populated, and I had a lot of problems with control voltage leakage into the audio signal, and this kind of deals with that. So this is a really huge resistor. That's something that I haven't really seen on this type of current source, so that's why I didn't have it populated initially, but I guess they kind of added it to deal with this problem of control voltage rejection at low cutoff frequencies. And I don't have this diode populated. I think this is just there to limit the current coming out of this thing and protect the OTAs. So you'll want to be careful when you first hook this thing up, because you can provide too much current to the OTAs and fry them, potentially. It didn't happen to me, but it's possible. So if you set the trim pots right. And this is the high pass filter, so this is the first one in the series. So to hook up a switch to select between your BJT and OTA filters, they have these header connectors or jumper settings or whatever you want to call it up in the center middle of the PCB. So the intent here is that if you hook these up vertically, if you jumper these two together, that'll select one filter, and if you hook them up horizontally, that'll select the other filter. So I've hooked up a single pole double throw switch, so I connect these A and B nodes to the center, and then I kind of crisscross the high and low. So this would be high, this would be low. If you have these shorted, A is going to be low, B is going to be high, and then if you have this side shorted, A is going to be high and B is going to be low. I think I did that right. So that'll select the two different filters. Schematics, right? I don't know if I just explained that right. But yeah, and then these are those two things I had to change to get the amplitude going into the filters to be the same. Or I guess the amplitude coming out. Not sure. A little confusing. Kind of derpy here. So, and then you know, these, instead of going straight to a Q pot, it goes out to a switch, which then goes to the Q pot, so that you can select the filters. So, you know, it's more complicated than you first might think, where you just hook up the input and the output. I think that's all there is to say, really. So, happy hunting, I guess. I'll post the schematic pictures and then just do an audio demo. So just a couple things I forgot. To explain that comment about the OTA getting fried, there's actually a history behind that. When I first hooked this up, the OTAs were getting really hot, and I figured out that they were getting too much current from the current source, so I turned down the initial cutoff frequency, and that kind of fixed the problem. You know, then they're in their good operating range. So I'll probably put a note on the schematics of what voltage you should shoot for. You know, so you could populate this first, set it to the right voltage, and then populate everything else. And speaking of the order of population, that's a pretty good segue. The way I did this mod was to put the switches on, take the 0 ohm resistors off, and then set the jumpers appropriately for selecting the Korg 35 filter. So that would be a good step before you start populating the filter. So that'll just verify that you've got the switches on right, and they can be selected, and they're, you know, doing what you expect. And then you put this filter on. So that would be a good suggestion, I guess, if you're gonna attempt this. I think it's really cool that they got this front panel so tight on the PCB that they cut out holes for the electrolytic caps. That's pretty cool. One thing to note is that you still have access to the trim pots that are available for the OTA filter, so I think it must have been pretty late in the project that they decided not to put the OTA filter on this product. So there's a switch. I just opted for a simple toggle switch because that's the most straightforward single pole double throw thing to do. And there's the kind of header connectors on the back, if I can get it to focus. So I just used some of those like digital debug wires or whatever for that. So keeping my fingers crossed, we'll hook it up and see if she still works. So don't mount the switch where it's mounted in the demo, because where I mounted it doesn't fit, and I had to cut this metal panel, which was a huge bitch. So mount it somewhere else. So there's the finished mod. It's just a switch. I'll do a quick demo and probably just a few filter sweeps and switch between the filters, and hopefully you'll be able to hear a difference in the character and the noise.